Hello students, under Algebra number theory, we are in Unit 2, Finite Fields and Polynomials, lecture number 5. Here in this lecture, we are going to continue the division algorithm. So for the past 3 lectures, I've been talking about division algorithm, who had invented, etc. So we'll continue with that. Let's get on to the presentation. So the first problem, if f of x is equal to 2x power 4 plus 5x square plus 2 and g of x is equal to 6x square plus 4, then determine q of x and r of x in z7 of x when f of x is divided by g of x. So as you know, the higher degree polynomial has to be kept as your dividend and the lower degree polynomial should be kept as your divisor, and you should stop the division until you get the remainder as 0 or degree less than that of your divisor. Okay, so now one more thing is here. So one more restriction is here is the z7 of x. It's a field, and you know what z7 contains? Set of numbers starting from 0, 1, 2, 3, 4, 5, 6 till 6. So now you have to find the quotient and the remainder in z7. So which means that all your coefficient of that particular division process should be between 0 and 6. Let's get on to the division. So 2x power 4 plus 5x square plus 2 is used as a dividend, and 6x square plus 1 is kept as your divisor. Take the first number and first number divided over it. So 2x power 4 divided by 6x square. So our answer will be x square, and you're getting 2 by 6, which is not allowed, right? So when there is a fraction, so we have to treat the numerator as a remainder. So we have to get that particular number such that the number when it was divided by 7 yielded the remainder 2. Just go on the reverse thinking. So now which number was it? So it's the best option number is 30. So if I'm going to divide 30 by 7, the remainder is 2. So we have to replace this by 30. Okay. So 30 divided by 6 will give you 5. So write 5 on the numerator, on the quotient term. So take 5x square and multiply it to the divisor. You will be getting 30x power 4 plus 20x square. Again, this 30 and 20 are not allowed. So 30 should be replaced by 2x power 4, and 20 again, it's a number which does not belong to the modulo set 7. So now we divide it over 7, the remainder is 6. So replace it by 6x square. Change the sign and try to cancel out this 2x power 4. And if you put a negative sign over here, I'm getting minus x square as your answer or as your remainder. Now minus x square again is not allowed because it carries a negative value, because the modulo numbers are starting only from 0. So minus 1 have to be replaced under modulo numbers. So will I replace it? Its carries a negative number, just add up 7 to it. So you'll be getting 6. So replace it by 6x square and bring down the only left out number, which is 2. And now again take 6x square and divide it over 6x square, and your answer is 1. Put it in the quotient place, take 1 and again multiply to it. You get 6x square plus 4. Now when I change the sign, 6x square get cancelled, and when I change the sign, I'm getting minus 2 over here, and my answer is minus 2. Again, minus 2 is not allowed since it's a negative number. So over minus 2, I have to add up 7 to it, and my remainder is 5. So my remainder is 5, my quotient is 5x square plus 1, and my divisor is 6x square plus 4, and my dividend is 2x power 4 plus 5x square plus 2. Combining all these 4 terms together using division algorithm, we get this particular equation. So write down the quotient, remainder, division algorithm, and replace all the polynomials in its particular position, and hence the problem ends. Hope you understood. So we move on to the second problem. If f of x is equal to x power 5 plus 3x square power 4 plus x cube plus x square plus 2x plus 2, which belongs to z5 of x, is divided by x minus 1, find the quotient and the remainder. Solution: given f of x is equal to a fifth degree polynomial is divided by a first degree polynomial. Since under Z5 it is mentioned, so we have to find out the numbers in the sets, right? From 0 to 4 is the field to find the quotient and the remainder in Z5. So we perform the long division method when g of x is divided by f of x. So let's get on to the division now. So now it's a very big polynomial. So take one term after the other. So it's going to be x power 5 divided over x. You get x power 4. So take x power 4, multiply to x minus 1. You get x power 5 minus x power 4. Change the sign, cancel out x power 5. And this becomes plus, so you get 4x power 4. Bring down this x cube. Again take 4x power 4 divided over x. You get plus 4x cube. Take 4x cube, multiply to x minus 1. And your answer is 4x power 4 minus 4x cube. So again change the sign. 4x power 4 is cancelled. And here you get 5x cube. 5x cube. Since it's modulo 5, it is not allowed. So dividing 5 over 5, your remainder is 0. So you replace it by 0. Plus, bring down the other two numbers, x square plus 2x. And now divide x square over x. You get x there. Take x and multiply it to the divisor term. You'll be getting x square minus x. Now change the sign, cancel out this x square. Now this has become plus. So 2x plus x will give you 3x. So 3x is allowed in the set. Again the last number, that is a constant term which is left out in the polynomial, bring it down. So you get 3x plus 2. Again take 3x divided over x. You get 3 as your answer. Use it in the new quotient. Take 3, multiply to it. You get 3x minus 3. Now if you change the sign, 3x will get cancelled. But here you are getting plus 3. So plus 3 plus 2 will give you plus 5. 5 is not allowed again. So you are going to divide it over 5. So your remainder is 0 here. So now the quotient term is x power 4 plus 4x cube plus x plus 3. And your divisor term is x minus 1. And your remainder is 0. Now using the division algorithm, you write down the quotient separately, remainder, and then by division algorithm we have dividend is equal to quotient into the divisor plus the remainder. So in place of dividend, we will be substituting x power 5 plus 3x power 4 plus x cube plus x square plus 2x plus 2 and quotient into the divisor, and the remainder was 0. So substitute everything and thus the problem ends. So this is the end of lecture number 6. So which means that you would have studied the division algorithm in detail, which was invented by the famous mathematician Euclid. So always try to remember there are two types of divisions performed: polynomial divisions under a normal category. So there is no restriction there. You can have any number of any higher power of whatever it may be, any coefficient you can have. But if there is any restriction given to you based on some modulo set, then you have to see to that all the coefficients of that particular division process lies within the set numbers. It should not be greater than the set numbers or outside the set. Even if it is a negative value, it is not allowed. Try to maintain a positive value and try to keep the coefficients strictly within that range of that given modulo number. Hope you understood division algorithm. Thank you so much for watching. We'll continue in the next lecture.